Welcome back. I'm Alan Hall.
I'm Dan Blewett, and this is the Uptime Podcast, where we talk about wind energy, engineering, lightning protection, and ways to keep your wind turbines running. All right, welcome back to the Uptime Podcast. This is episode 40, and on today's episode, we're going to talk about a recent article in Wind Systems Mag that featured WeatherGuard Lightning Tech. So cool little quick hit there. Some news on the Nobles 2 wind farm. Siemens Gamesa now partnering with Orsted on their first onshore project, which is really commercially interesting. Some interesting topics out of Australia. One of their coal plants has been essentially written down as worthless. So we'll talk about the tax implications and just the story in general, which seems a little bit strange. And then lastly, in our news segment, we'll talk about ocean acidity and does this actually purport to increase lightning strikes on water. In our tech segment, we're going to talk about the GE Cypress, their new 6 megawatt wind turbine. And then lastly, Catapult, the ORE, they're doing some additive, they're adding an additive cell, potentially exploring new 3D printing technologies for wind turbine blades in the future and other aspects of technology. So, Alan, let's start with Nobles 2. They've had some issues with lightning, it seems.
They have some brand new Vestas turbines, and the site just got turned on a couple of days ago, from what we can tell. Mm-hmm. It's up in Minnesota, and they've had 7 blades already damaged by lightning. 6 of them are going to be removed and repaired/replaced. It sounds like one's going to be tried to repaired in situ on the turbine. It's what it sounds like. So the site has barely even started, and they have 6 blades that are getting essentially replaced for some lightning protection issue. And the press release is funny because it does say that Vestas knows they have the B136 blades, as it's described, have a known lightning issue, which when we reported earlier a couple of months ago on the, wasn't it, Dan, $175 million write-down from Vestas for lightning issues?
Yeah.
So it must be all tied together. But we haven't heard exactly what the lightning issue is besides they're seeing lightning damage. Have you seen anywhere where it's discussing what the engineering issue is?
No, they're keeping it pretty close to the Vestas. Oh, zing. And you and I both scoured the web and haven't really found much on it. So it seems like it's trying to keep it proprietary, I suppose.
But all the operators must know at this point, or at least you think that Vestas would have reached out to the affected operators to tell them to keep an eye on this situation, because you just don't want a blade breaking off and hitting the ground if you can avoid it. Just too much risk to employees. But I think it is interesting that it is so quiet in the press about what the issue is. There's just no curiosity about what actually is causing this, which is I think it's unusual, because in most of these type of situations we would know something about what the engineering issue is, but it's tightly held.
Yeah, for sure. Well, and that brings up your feature article in Wind Systems Magazine. So you had a company profile Q&A. Tell us a little bit about what you shared, and it's interesting because WeatherGuard Lightning Tech is unique in the wind industry. Like, there's not really other companies that are focused on an outside solution from a blade manufacturer to repairing these lightning issues.
Right, because once the blade is in service, there's really not a lot you can do to the blade to improve its lightning protection. So our product, which is technically defined as a segmented lightning diverter, is something that can be added onto the exterior of the blade near the receptors and greatly increases the lightning attachments to the receptors and away from the structure. So it's a relatively simple upgrade to most wind turbines. And you're right, there's not a lot of other things you can do to a turbine right now on the lightning protection side besides start cutting into the structure and doing major overhauls to the blade, which involves then, of course, taking the blade off the turbine and having a crane and having people on site and all the expenses that are tied up in that, where our solution involves standard technicians working on ropes, adding our product to the receptor areas of the blades, with no structural implications to the blade itself. So, it's just a cleaner solution for most blades that are out there today.
Well, and a quote from you from the article is that protecting the blade typically only requires a couple feet of strike tape, which is your lightning diverter strip. And that should come as like a breath of fresh air for companies that, like, yeah, we are having a lot of lightning issues. Like, maybe we should just give this a try if it's just a quick, send someone up there, put on some epoxy and apply a couple feet of it.
Right. It doesn't take a lot of strike tape to greatly improve the blade lightning protection. As we talk to the operators and managers at different wind sites across the world, they're kind of shocked how inexpensive it is to actually do this. And it usually doesn't take a great deal of energy or time to install it. And if you have technicians that are scheduled to be up on blades already, then improving your lightning protection system is really, really easy and inexpensive. So it really makes a lot of sense to make that improvement when you can, right? And right now, as we're into December and it's getting near Christmas and the new year, a lot of wind turbine managers are scheduling for the springtime, and that's what we're involved in right now. So a lot of scheduling for the springtime. As soon as the snow melts and they can get back onto the site, they were going to start making the repairs that happened late in the season this year, and then making the upgrades for a variety of reasons, if it's vortex generators or friction structural problems they're having. And on top of that, they want to increase the resiliency of the lightning protection system. So our strike tape product just really fits in nicely to what the operators and managers are scheduling into the spring.
Yeah, so definitely jump over to windsystemsmag.com, and we'll put the link in the show notes below so you can check out the article on WeatherGuard Lightning Tech. So moving on, Orsted and Siemens Gamesa are partnering for an onshore project for the first time. So the Haystack 298 megawatt wind project in Nebraska is going to feature 51 Siemens Gamesa 5.0-145 wind turbines. Again, the lovely names. We'll talk about GE with their Cypress turbines later. But they hope to come online. It's supposed to come online in the end of, what says here, fourth quarter of 2021. Maybe that's that seems really ambitious, but that'd be cool if they get this up and running by next year. Yeah. So why is this significant? Obviously Orsted and Siemens Gamesa have worked on offshore quite a bit together, but do you feel like this is going to be another long-term, is this the first of many onshore projects for them?
I think onshore for them is going to happen more and more as they realize there's opportunities to do it. And it's to put a wind turbine site in Nebraska is relatively simple, because there's not a lot of obstacles anyway. You're not putting on top of mountaintops. You're not, it's easy in, easy out. You have plenty of available people to work on these things. So the wind turbine site's up in sort of northeastern Nebraska, closer to the South Dakota border, which is mainly farm country. And if you can find opportunities like this, which are relatively simple, to get in and get out and start producing energy and getting your return on the investment, you're definitely going to do it. Orsted obviously has been mostly involved on offshore with Siemens Gamesa, but Gamesa itself has built numerous, and Siemens too has built numerous onshore turbines for forever. So now it's just another opportunity to sort of grow together. And I know they're trying to build that relationship, and it makes sense from the Orsted point of view. It makes sense to have that long-term relationship with a company that you've worked with and trust and can get projects done. Because the most important thing about all of this is that the project gets done on time and you're not overspending to get it in place. Right? So consistency of the project cost and the timeline is really important to the bottom line of the project.
Yeah, and so tying into that, it's interesting. It says it'll power up to 85,000 homes, which is just an insane amount of homes. It's really interesting what obviously wind power can do. And so there's a story out of Australia where the Blue Waters coal-fired energy plant is now being written off by their Japanese owners as worthless on the books. So obviously this has tax implications and all that. This isn't necessarily saying that they're shutting down the plant, right? But this is saying that they're not super excited about their prospects of getting their money back in the future. But what jumps out at you this article, and is this going to be a trend going forward? Are coal plants essentially going to be obsolete?
Well, I don't know if they're going to be obsolete, but it's going to be harder and harder to operate them without having severe restrictions placed upon them. Obviously, there are different versions of coal-fired plants, right? So in the United States, there was a big effort to clean up the emissions from the coal-fired plants, and some of them have shut down in the United States. There really hasn't been a new coal-fired plant built in the United States in a couple of years. So it's just going to get harder and harder and harder to do, I think. It does, when you get into these large financial transactions, and we're talking about $1 billion+ here, when you start talking about financing $1 billion+, there's a lot of implications into that of who's holding the note, how much interest they want you to pay on the loan, when do they want it paid by, can you afford to make the payments? And if you think about it in a large corporation like that, essentially what they do is they make every single project its own separate company. So if one of them goes down, they can just segregate it from their other companies that may be making money and sort of write it off or bankrupt that part of the company. So that's when the negotiations start about who's paying what, is it going to bankruptcy court. That sounds like where they're headed right now. So there's to say that they're going to shut down the plant, I think is a little premature. There's a lot of variables that go into how you finance and what value you place on a particular asset for any company, not just a coal-fired plant. So it's going to be interesting to watch, and hopefully the media reports actually what's going on, because the conjecture is, well, there's so much solar in Australia, they don't need coal-fired plants. I don't think that's true, because at nighttime, what are you going to do, right? But there is a need for some continual power source during the cloudy days and at nighttime to keep the lights on in Australia. So they need some other power source. Coal has been an easy one for them, but as the energy fluctuates and all that kind of, all the variables that applied there, it's putting stress on the financing of coal-fired plants for sure.
Yeah. So last story here in our news section, ocean acidification may be increasing the intensity of lightning over the oceans. Alan, I'm just going to let you run with this. So this is a research study out of nature.com published this article, and it's got a lot of references. Very academic paper, but you've got some issues with the summary and conclusions, I believe.
Well, if you read through the article or a paper, you get to the actual testing or the simulation that they created. It's just based on some testing they did with a high voltage power supply, 2 electrodes, and some water. It's essentially it. But the test was run such that, if you think about in a very simplistic terms here, you got an electrode 1 centimeter above some water, and in the water 3 centimeters deep is another electrode. And then they're changing the alkalinity of the water as they run these little experiments to see how the flashover happens between the electrode above the water and the electrode in the water itself. That's generically what's happening there. And then, so the recorded data, all that's fine. All the recorded data there, whatever. When the extrapolation happens between this little laboratory experiment, and I mean little laboratory experiment, they're moving arcs 4 centimeters, which is a little under 2 inches. And you're trying to extrapolate that to world lightning strikes and to any lightning strike, which the lightning channel is moving a mile or two before it hits the ground. There's really no correlation between them. It's all conjecture, because if you think about the acidity, let's just describe it in a little different terms. Lightning strikes all over the world, and there's all kinds of soil. Forget about the ocean for a minute. There's all kinds of soil, rocky mountains to very black, nutritious dirt all over the place. The ground doesn't really change. The ground resistance or the ground composition or the ground alkalinity, acidity, whatever, doesn't change whether lightning happens there or not, because lightning mostly starts in the cloud and starts traveling towards the earth, and it doesn't really care where it goes. It's already started. The cloud started the process. The ground is just the recipient of it. Same thing for the ocean. It's just going to be the recipient lightning strike. So making an argument that global, and what they're trying to make is this argument that the oceans have become more acidic over time because of CO2 in the air and CO2 in the oceans. It's going more acidic. Therefore, it's going to change the nature of lightning strikes. That's a huge stretch. Now, the problem I don't have a problem with the experimental set that they document, all that's fine. Where I have trouble is when they try to extrapolate to the global lightning world. How accurate is that? And quite honestly, when you make those kind of statements and they show up in nature.com, you better be able to back that up. And you should be held somewhat responsible for writing that article. Because if it turns out that's not the case, then why was it written in the first place? You're making a huge leap. And I know what happens is that there's that incentive to do that because it gets you in nature. It's what it does. If you can say global warming is going to be catastrophic to the world, that's going to get you in nature. If you're saying some global change is going to make it better for life, it's probably not going to be in nature, honestly, right? It's sort of the dog bites man, man bites dog scenario, right? The man bites dog is going to be in the paper. So I think there's got to be consequences here. Not consequences in a sense of, there should be some financial, or these authors should be sued if it doesn't work out. But I do think you got to follow their work and see if their trend of work is actually producing reliable results or is it not. And if it doesn't, then we need to discount that. So you are taking a risk as a scientist to put this out there and to make these kind of claims versus just saying, hey, we did some experiments on the alkalinity of water or the acidity of water, and it's changing the way electrical sparks happen. Fine. So I'm just troubled by this, and I see it a lot more recently on the sort of the global claims of lightning. Lightning's going to increase because of global warming. Lightning's going to decrease. Lightning's going to cause more fires. Lightning's not going to cause more fires. You can get both sides of it. And it gets back to trusting, quote unquote, experts, right? You have to have some sense of skepticism in any of this when it makes global predictions. You just have to.
All right, so in our tech segment today, we're going to start with the new GE Cypress. They have a 6 megawatt onshore wind turbines, their biggest of their Cypress family. And one of the really interesting, and this is what I want your take on, Alan, one of the interesting aspects of this is that the blades are two pieces. So we've talked about this a little bit in the past. It's hard to find a lot of information on the exact technical specifications and how these are fit together.
Right.
Article from Composite World shows an interesting drawing of a Siemens Gamesa two-piece blade. So that's helpful and they're probably similar, right? I'm sure the designs aren't incredibly off, but the general principles are probably the same. But, before we get into some of the power production specs, how do you feel about the two-piece blade design? And are we going on the assumption that GE's done a lot of testing? And that seems to be the assumption, right? That they're like, hey, this is good to go. Or is this still like yet to be seen if these blades are still intact 5-10 years from now?
Yeah, the issue is not so much that it's a two-piece blade. It's a two-piece blade with carbon fiber. And from the lightning standpoint, you've basically broken the electrical path between the tip and the root of the blade with some sort of structural joint, which is also now an electrical joint. So if you take a lightning strike to the tip, it's going to travel down some way. Some part of it's going to be in the carbon fiber. It's hard to avoid that. It's going to cross through that joint. Even some part of the lightning is going to go through that joint. I don't know how you would avoid that. And then rush down to the hub. So the question is, structurally, can it handle it? More than likely, they'd have to. GE would have to have done hours and hours of simulations and then actual structural testing to verify the joint of that blade to make sure that it's going to basically fatigue test it to make sure it's going to last a 20-year lifespan, in which they're saying it will. The second part, though, is sort of the randomness of lightning and how lightning is going to affect those blades. As we have just seen with Vestas on their 136 blades, they thought they had a blade that was fine, and then they put it out in service, and then it doesn't work. Right? So there's some variability in lightning, which is not necessarily getting incorporated into the basic blade design. And when you add the variable of carbon fiber to it, it gets even more complex than just basic fiberglass blades. So you hope that they've thought through this enough and are monitoring it enough. Part of when I started reading about sort of the segmented blades or two-piece blades, my thought was, first, you need to instrument it to monitor that joint. You need to make sure that I'm sure it's some sort of bolted joint, you need to make sure that the bolts are doing what they said they're going to be doing, that nothing is coming loose, that the loads in that joint are as predicted in your computer models you should be doing that. So as soon as you start to instrument those blades, which hopefully they're doing, you're putting wires and electrical pathways up into that joint also, which can get affected by lightning. So it's a very, very, very complicated problem that we're going to have to just continue to monitor as time goes forward. The reason for the two-piece blades, obviously, is sort of the transportation and manufacturing costs. Manufacturing costs are going to go up because you're going to create this really intricate splice joint of some sort. So the manufacturing costs are going to go up, but the intent is so you're having easier access or smaller blade sections to transport to maybe more remote areas, which also makes sense, right? So they're playing a trade-off between the cost of the manufacturing effort versus the cost of the transportation effort, and somewhere there's a happy medium. But Dan, all these since the wind turbine industry doesn't seem to have a great handle on lightning protection right now, it's just a note of caution, like, hey, we just got to keep an eye on it.
Yeah, and it seems like you said, that's the variable they can't as much control for. Like, obviously with construction techniques, all these new skyscrapers and buildings, I mean, they're all designing these solutions and these joints, and they go up on these buildings and they expect them to work, and they do, right? So I guess you would assume that the same thing would be true with, like this joint on these blades and all the engineering and manufacturing. But like you said, those are other variables that they can't really test shooting lightning through the joint over and over and over, right? So that seems like something that they're not going to know until it's out in the field.
Very, very hard to predict, and based upon where the first installations were, you may have a very false positive in a sense that you just don't take a lot of lightning strikes, versus if you put them on the west coast of Japan or places in Italy or in Croatia or locations which have really high intensity lightning, you may get a totally different answer from those places. So even some of the first installation may not tell you a lot long term.
Yeah, well, and this one's it's a enormous turbine, right? It's 100. they have two versions, 112 or 167 meter hub height, which is just gigantic. Yeah, 164 meter rotor diameter. So it's going to be imposing driving up and seeing those in Nebraska, and just that's so big. That's like, this is not a technical. That's so big. These things are huge,
especially in Nebraska and places, or Kansas or Oklahoma, or Iowa, places where it's normally flat. You don't have anything relative to put it up against. It gets a little hard to tell how close you are to some of these wind turbines because there's no reference point anywhere. There's nothing around it besides corn and cows and farmland. So they are enormous structures.
Yeah, and I'd be curious what the noise profile is like, and just all those other things. Yeah. I'm sure they're, like you said, they just keep getting more and more complicated. And that's why you don't see the 12 megawatt ones onshore, because they're just so, besides transportation and logistics and all that stuff, it's just gigantic. So last thing on the docket today, some news out of the Catapult facility in Scotland, and they're talking about doing additive. They're adding a cell of additive manufacturing. So, the common term is 3D printing, right? Mm-hmm. So they just want to add this cell because they act as an accelerator, and they're just trying to see how fast they can boost their offshore renewable energy resources. So do you see 3D printing blades? This will be my first question to you about this. So they're adding this cell to their accelerator, right? So they can do additive and 3D printing. Mm-hmm. But do you see them actually being able to 3D print a blade, or is this more just for prototypes and just being quicker to market with testing things out? Well,
conceptually, you'd want to be able to 3D print blades wherever the turbines are going to be located. And that would be the ultimate goal, is that you don't have to transport the blades anywhere. You can actually make them on site. Excuse me. So the only issue is transporting the raw material into the machinery on site, so you can push out these blades. The 3D printed efforts that I have seen over the last year that have been more advanced, you're seeing 3D printed products with basically thermoplastics with fibers in them, carbon fiber, fiberglass mixed in with them that you can then lay into different forms. It's like a 3D printer kind of thing. But how effective that's going to be on such large structures is yet to be determined. You'd think you'd see a lot more of it on the aerospace side first, because they have the cash to do it typically, and the ability to invest in that long term, versus wind, which typically won't do that. But the ORE Catapult is doing a lot of great things, quite honestly. So if you actually watch their website, LinkedIn page, you see all the sort of the breakthrough things that they're doing, and they're really forcing the issue of, here are some technology areas we need to see improved. We're going to put some funding behind it, and we're going to create this little bit of chaos to look at different ideas. Throw us some solutions. Let's check them out. The 3D printed obviously is one of those solutions, which, in the top level generic sense would be a great idea if you could implement it. Obviously, the problem is trying to implement something as complicated, technically complicated, and it involves a lot of structural loads and those kind of things. So it's not a tomorrow project. Like, we're not going to see 3D printed blades in the next year, but 5 years down the road, possibly. But it's going to take a lot of work to get there.
Now, the different ways of, you would know way more about the way they, create carbon fiber and composite structures. Does it have to be, layers of fabric and then the epoxy resin systems and all that? Does it have to be sort of directionally like that? Because it seems like you lose some of that functionality when you're doing 3D printing. Like, you don't have a length of a sheet of carbon fiber.
Right. So,
exactly.
Right. So think of it as carbon fiber or fiberglass as being little bits of rope. Ropes are great in tension, but they're awful in compression. When you put a coating on it, like an epoxy or some sort of thermoplastic, then you can also have some compression ability, but it doesn't really like it. So there's a lot of things about it. But you're right. When you have a chopped fiber, like on a boat, boats tend to be chopped fiberglass epoxy sprayed on. The load path, there's really not a load path like that, right? So on a blade, the load path is along the length of the blade, obviously, because it's the one surface is in tension, one surface is in compression most of the time. So the complexities are much higher on something as complex as a wind turbine blade, where you want to know where the fabric is going and how much fabric is going that particular direction, and what essentially the strength of that fabric is. This is why there's the switch from fiberglass to carbon fiber. It's lighter, but it's also stronger overall, so to speak. So yeah, the 3D printed chopped fiber things that I've seen, the benefit of the chopped fibers, it holds the plastic together better. It's not as brittle as some of the early 3D printed things are. But you're right, you don't have a consistent way to know how much load it can take, and that's going to be the trouble.
So would the application maybe be for like internal parts? Like, could a 3D print pieces of spar and just like other components maybe faster?
Well, I don't think they're going to be doing a spar, but let's look at the 3D, the two-piece blade that GE is talking about and Siemens Gamesa are also doing. Somewhere in the middle of this two-piece blade, there's a joint, and in that joint they're going to have some sort of cover. Well, you could 3D print the cover, that fairing, because there's really no structural load there. It's just a cover, so it's something you could 3D print. And then there's a lot of other uses for 3D printed products where just the complexities of making it, machining a part, are so expensive that it's just easier just to print the thing. But there are all kinds of applications for 3D printing in every aspect of life today. We haven't just implemented it. One, is still expensive, and two, we haven't really figured out how to do it yet. So it's a new technology, and you always have to give new technology 5 to 10 years to kind of roll into fruition, sort of like the iPod. It just takes a long time for people to realize they can put 1,000 songs in their pocket. That ability was there 5 years prior, but no one had done it like Apple had. So the same thing here is happening in 3D printing. You're seeing this sort of consolidation, and all the engineers start to focus on a little bit more than they had 5 years ago. And then you're going to start to see a lot more products in wind, in aerospace, in all aspects of life. You're going to see a lot more 3D printed stuff coming out.
All right, well, we're going to wrap up today's episode of Uptime. If you're new to the show, welcome. If you're a regular here, thank you for your continued support. Please subscribe to the show and leave a review on iTunes, Spotify, or wherever you listen to podcasts. Don't forget to check out the WeatherGuard Lightning Tech YouTube channel for video episodes, full interviews, and short clips from each show. For Alan and all of us at WeatherGuard, stay safe and we'll see you next week. Is downtime causing you financial pain and putting a stop to your power production for months on end? It's no secret, lightning strike damage is a major cause of wind turbine downtime. This damage is preventable with our easy-to-install strike tape lightning protection system for wind turbine blades. Our incredible engineering, build quality, materials, and edge sealants withstand up to 5 times more abuse in the toughest weather and lightning conditions. And we've got the research to prove it. If you're tired of constant downtime, we can help. Reach out to us at weatherguardwind.com and schedule a free call. We'll get your uptime back in no time.